All right, today, section 8.2, our objectives are the student will be able to simplify rational expressions and the student will be able to multiply and divide rational expressions. Now, first of all, remember a rational number is any number that can be written as a fraction. So you've worked with fractions for a long time now, and I know it's not your favorite thing for a lot of you. But we're going to simplify rational expressions. So an example of simplifying might be 12/18. Now, it's something you might be able to do in your head and just say, well, I know that 12/18 reduces to 2/3. But let's take a look at some steps that will help us through this. So, to simplify rational expressions, the first thing we want to do is factor the numerators and the denominators. So let's go back to that 12/18. Okay? Well, I can factor that. Factor, remember, means break it into numbers that multiply together to give you that number. And when you first learned this, you might have done it by prime factorization, where you took the 12 and you just broke it into 2 times 6 and then 2 times 3. And so that 12 could be rewritten as 2 times 2 times 3 or as 2 squared times 3. And then the 18, if I take the 18, I can break it into 2 times 9, and then the 9 into 3 times 3. And so that could be 2 times 3 times 3, or 2 times 3 squared. Okay? So that would be factoring the numerators and the denominators. Our next step is to cancel like factors. So whether I did it here and said, oh, there's a 2 in both, and there's a 3 in both, so I get 2/3. Or if you remember when you have exponents, if you have the same base and you're dividing, you subtract powers. Since there's no power there, it's to the first, so 2 minus 1 is 2. And then, or you could say one of these 2's cancels. And the same thing here. 1 minus 2 is a -1, but we write it on the bottom then, and so that would be 2/3. And so I can say this 3 cancels one of those. In either case, I get 2/3. So it's fairly easy with fractions, but now we're going to start complicating this and getting expressions into the problem. So let's take this problem. 6x to the 7th over 2x to the 4th. Now again, it's fairly easy. You don't need to factor these. You can just say, oh, I know that 2 goes into 6 3 times. And so I can say 2 cancels the 6 and the 6 becomes 3. And then the variables, I just reduce. So I divide that. 7 minus 4 is 3. And so this 4 cancels 4 of those, leaving me with an x to the 3rd, and so my answer is 3x to the 3rd. So that way we cancel the factors, we get 3x to the 3rd, and then we have one step we're going to add now that we've made this a little bit more difficult. We're going to list restrictions, and that's what makes the denominator equal to 0. Because remember, we can't divide by 0, and to do that we go back to the original problem and we look at our variables. Since there's an x in the bottom, we have to ask ourselves, what would make that denominator equal to 0? What would that variable have to be? So since this is 2 times x to the 4th, the only thing that times 2 gives you 0 is 0. And so we know that x cannot equal 0. Now the book, I will tell you, when they write the restrictions, they will say the restriction is x equals 0 is a restriction, which means you can't use it. I'd prefer that you just write it this way. X cannot equal whatever makes that denominator 0. So again, this is a fairly easy one. And so we're just going to go through some more examples and make sure we're okay on this. So let's take it a little bit more complicated. Let's take x squared minus 2x minus 3 over x squared plus 5x plus 4. Now I will tell you the first thing that I often see people do is they say, well, I've got an x squared on top and an x squared on the bottom, and they just cancel those out. And they get negative 2x minus 3 over 5x plus 4. Well, we have to remember that when we reduce fractions, you know, everybody says, why isn't that possible? But we know why it's not possible if we look at, let's take 6/11. All of you know that 6 over 11 cannot be reduced because there's nothing that goes into 6 and 11. But if we use the theory we used here, I could break that into 4 plus 2, and I could break this into 4 plus 7, and then cancel the 4's and get 2 7's. But then I could break that down into other additions, and I could get to where eventually we get 0. So you can't cancel things unless they're multiplied together. So if we just go back, we can't cancel those out, and else if it's got something added or subtracted to it, you can't cancel it out unless you cancel the whole thing out. So here's where we're going to get into where the real factoring takes place. We have to factor both the numerator and the denominator. So I know most of you learn factoring by the x method. I'm just going to go ahead and factor these without doing the x method to save some time. Now my advice is no matter how you factor, always take the time to check it to make sure you didn't make a mistake. It doesn't take very long. X times x gives me the x squared. The negative 3 times 1 gives me the negative 3. And then a negative 3x and a positive x add up to a negative 2x. So I know that's right. Same thing on the denominator. X times x is x squared. 4 times 1 is 4. 4x plus x is 5x. So I know I've got that right. So we factored the numerators and denominators. So now we go to the next step. We cancel the like factors. Well, our like factors in this case are the x plus 1 and the x plus 1. And so our answer is x minus 3 over x plus 4. Now, I leave the parentheses there. The book may not. It doesn't make any difference unless you have something outside. You can drop the parentheses. That's all that's left. If you have two things left in either the numerator or the denominator, then you do have to leave those there. But now we have to finish by writing our restrictions. What can x not equal? Okay? And we go back to where we factored. And we just ask ourselves, what would x be that would make this 0? And again, when it's written in this format, all you have to do is the opposite of this. So negative 4 would make that equal to 0. So it can't be negative 4. And you also have to do it for ones that are canceled. So x plus 1, our restriction would be x cannot equal negative 1. And so this is our answer, and this is our restrictions, and we're done with that problem. Let's go to a little bit more difficult one. (6x squared plus 7x plus 2) and 6x squared minus 5x minus 6. So a little bit more difficult. Again, we can't cancel the 6x squareds because they've got stuff added, subtracted to them. So we have to factor that. Now remember, when you factor, the first thing you should always check for is the greatest common factor. In this case, we don't have any in the numerator or the denominator. So I'm going to go through and review the x method with you. So remember, when you factor, we'll do this one. The top number, you multiply a times c, so 6 times 2 is 12. And the bottom number is your middle term, 7. And now we have to take the numbers that multiply together to give me 12 and add up to give me 7. So in this case, it would be 4 and 3, and you just put x's with those. Again, that's because this is x squared when you multiply that. But now here's where you have to remember, because we have a number other than 1 in front, we have to build the box. So remember, when you build the box, there's your first term, 6x squared. Our last term goes in the last box. And then these fill either box, it doesn't make any difference. So I'm going to go 4x and 3x. And then we pull out the greatest common factor. The greatest common factor of 6 and 4 is 2x, because I have an x in both. The greatest common factor of 3 and 2 is 1. Remember, your sign is always the first box that you took the greatest common factor out of, so that's plus. Same thing going down. Greatest common factor of 6 and 3 is 3, and then I have an x in both. And then 4 and 2 would be a 2. Again, the first box is positive, so it's plus. So my numerator factors into 3x plus 2 and 2x plus 1. So that's just the numerator. Now let's go to the denominator. So I'm going to go ahead and just erase this stuff. So again, we multiply, we get negative 36, and we get negative 5. So now we have to find the factors that multiply together to give you 36, negative 36, and add up to give you negative 5, and those would be negative 9 and positive 4. Again, if we plug those in, our first box, the same way, 6x squared. Our last box, negative 6. And then our other two, again, it makes no difference. I'm going to go negative 9x and 4x, because remember you have to put the x's with those. So now we pull out the greatest common factor. This way it would be 3x, my first box is positive. 4 and 6 would be 2, my first box is positive, so plus. 6 and 4, 2, and I have an x in both. And 9 and 6 would be 3, but my first box is negative, so it's negative. And so this factors into 2x minus 3 and 3x plus 2. Now again, if you get in the habit of just checking your answers, 3x times 2x is 6x squared, 2 times 1 is 2, then we have 3x and 4x adds up to 7x, so that works. 2x and 3x is 6x squared, negative 3 and 2 would be negative 6, and then we get a negative 9 and a positive 4, which gives me negative 5. So we know we've got that right, cuts down on mistakes to check it. Now we cancel like factors. Well, again, it has to be the same. So the 3x plus 2's cancel, so I'm left with 2x plus 1 over 2x minus 3. And then my restrictions, what can x not equal? So again, you can take this and set it equal to 0 and solve, but remember the shortcut is the opposite of this. So the opposite of negative 3 is positive 3, divided by the number in front, so 3 halves. And so then also we have to do it for this one. The opposite of 2 is negative 2 over 3, and so my restrictions are x cannot equal 3 halves and negative 2/3. Now, what are some things that they can do that are little things that could throw you off? Let's look at this problem. 2x minus x squared over x squared minus x minus 2. Well, first of all, I always like to write these in standard form. So that would be negative x squared plus 2x. This one's okay. So when you pull out the greatest common factor, if you just pull an x out, I'll show you what happens if you just pull an x out. You get x plus 2. Actually, you get, sorry, negative x plus 2. Over, and if we factor this, that factors into x minus 2 and x plus 1. Well, if we go to cancel, we don't have anything that's the same, but if you notice, this is a negative x, positive x, 2 and negative 2. If they're opposites, what you can do if they're opposites, you can just pull a negative 1 out of that, because if I pull a negative 1 out, that becomes x minus 2. So what you probably would have wanted to do in the beginning was pull out a negative x, but it doesn't make any difference when I pull that negative 1 out. I get negative x times x minus 2 over x minus 2 times x plus 1. We cancel the like factors, and then we list, so our answer is negative x over x plus 1, and our restrictions are x cannot equal the opposite of this, so 2, and the opposite of that, negative 1. And we're finished. And that's what you're doing on the simplifying. Now the other thing they're going to have you do on this is do multiplication and division of rational expressions. Alright, so we're going to do a lot of the same process. Now we're going to be working with, let's say, let's just take a fraction. 4/6 times 9/26. Now you could multiply those together and then reduce, but I prefer just to use cancel before so we don't have to reduce afterwards. So in this case, I can say that 2 goes into 4 twice, and you can take the 2 into either one of those, you just can't take it into both. As long as it's in the denominator, it doesn't have to be across, it can be straight up and down. So I'm going to take 2 into that and make it 3. Then I have a 2 here, so that becomes a 1 that goes into 26, and that gives me 13. I still have a 3 here that goes into the top, so 3 goes into 3 once, and 3 goes into 9 3 times, and we get 3/13. Okay? Now you could have multiplied that and gotten 36 and gone 6 times 26 and then reduced, but it's a little easier to cancel beforehand. So we're going to do multiplication and division. So let's just review our divisions with fractions before we add expressions to it. Let's take 4/6 divided by 8/15. Now, hopefully we remember from early on in your math career when you first learned how to divide. We don't divide fractions, we change it to multiplication, and we multiply by the reciprocal of the fraction after the division sign. Now remember, reciprocal means to flip it over. So that would be 15/8. And now we do the same thing that we did before. 4 goes into 4 once, 4 goes into 8 twice. 3 goes into 6 twice, and 3 goes into 15 5 times. And so I'm left with 5/4. So fairly easy when it's a fraction, but what if we have an expression, an algebraic expression? So what if I have something like this? X plus 2 over 3x plus 12 times x plus 4 and x squared minus 4. We're going to follow these same steps. We're going to factor our numerators and denominators. Now, if you can't factor something, like in this case, I can't factor x plus 2. There's no greatest common factor. We can't do the x method unless it's a quadratic. So if you can't factor it, my advice is put it in parentheses. You can only cancel if you cancel the whole thing. When we do the bottom one, remember you should always check for greatest common factor. And in this case, 3 goes into both of those. So my top is going to remain the same. My bottom I can pull a 3 out of, and I get x plus 4. Times, over here we can't factor that, so I'm going to put it in parentheses. And x squared minus 4, hopefully we remember factors into x plus 2 and x minus 2. It's the difference of 2 squares. The only way you can do a binomial, 2 terms, is if it's minus and you can take the square root of both those. So the signs are opposite, and we get that. So then, follow our steps. We cancel the like factors. So I can cancel the x plus 2. I can also cancel the x plus 4. Now, if everything cancels on top, it's the tendency I see is people just forget about it and they put all this on the top. Remember, the denominator has to stay in the bottom. The numerator has to stay on top. So since it all canceled on top, it's just a 1. And then on the bottom we have 3 times x minus 2. Now again, if they ask us for our restrictions, we have to go back. X cannot equal the opposite of this, negative 4, negative 2, and positive 2. All right, let's take a closer look at a little bit more difficult one. Let's go 10x minus 40 over x squared minus 6x plus 8 times x plus 3 and 5x plus 15. Alright? So we factor, pull out the greatest common factor, we can pull a 10 out, and we get x minus 4. Again, I know you can do the x method, x minus 4 and x minus 2. Again, check it, x squared yes, positive 8 yes, negative 4, negative 2 is negative 6. So that checks. I can't factor that. Again, check greatest common factor, I can pull a 5 out. We cancel like factors. I have a 10 here and a 5 here. So 5 goes into 5 once, 5 goes into 10 twice. The x minus 4's cancel. The x plus 3's cancel. So I'm left on top with a 2, and on the bottom with an x minus 2. And again, my restrictions are x cannot equal the opposite of this 4, the opposite of this 2, and the opposite of that negative 3. So if you can factor, these go pretty fast, and they're fairly easy to do. Let's take a look at the division one. X to the 5th minus 4x to the 3rd over x squared minus x minus 2, and then divided by x to the 5th minus x to the 4th minus 2x to the 3rd over x squared minus 1. Now, when you're doing division problems on your assignment, I wouldn't bother writing down the problem that way. All you want to do is keep the first fraction the same, change it to multiplication, and then flip this over. Okay? Now, we do our factoring. Check for greatest common factor. I can pull an x cubed out of both those. So I'm going to go ahead, let's go write this down a little bit. X cubed, and then that would be x squared minus 4. Now, here's a case where I can factor that further. So I can go ahead and factor that. This is the difference of two squares, so that becomes x plus 2 and x minus 2. So my numerator is now this. My denominator, that's x minus 2 and x plus 1, times, again, this is x squared minus 1. That's the difference of two squares again, which is x plus 1 and x minus 1. Here I can pull a x cubed out, and I get x squared minus x minus 2, which then factors. So I get x cubed, and then I get x minus 2, x plus 1. Again, if you need to use the x methods on that, that's fine. Then we cancel the like factors, so the x cubes cancel. I don't have an x plus 2 on the bottom, but I do have... Now, here we have two x minus 2's. You can only cancel 1 for 1. Then I have an x plus 1. Again, I have 1 here. I have 2 on the bottom, but only 1 for 1. Doesn't make any difference which one. And then an x minus 1. So I'm left with x plus 2, x minus 1, over x minus 2, x plus 1. Now these aren't opposites, so we can't cancel that any further. If it was a negative x and a negative x, then we could, but in this case you can't. Now we still need to do our restrictions. Now you have to be careful with division, because we have to do restrictions for anything that was ever in the denominator. So this is in the denominator now, so x cannot equal 2 or negative 1. This is an x cubed, so x can't equal 0. We already have that x can't equal 2, and we already have the negative 1. We also have to go back up to these because they were at one time in the denominator. So x cannot equal negative 1, which we have, but it can't also equal 1. So I would have to add that. So if it was ever in the denominator, you have to give it as a restriction. One other thing they're going to ask you to do on this assignment is to solve some algebraic equations. If you can do this first part, the next part's pretty easy. Let's take x squared plus 3x minus 4 over x minus 1 equals 5. Okay? So we're still going to do the same thing. We're going to factor. So that factors into x plus 4 and x minus 1 over, I can't factor that, so I put in parentheses, equals 5. The x minus 1's cancel, and so we get x plus 4 equals 5, and then we subtract 4, and we get x equals 1. So our answer is 1. Now here's where you have to be careful, because we need to consider those restrictions. What can x not equal? Well, x cannot equal 1. That would give us 0 in the denominator. So even though we got 1 here, we have to cancel it out. And so in this case, there would be no solution. Now, they don't always cancel out. And sometimes maybe there's two answers and one cancels and the other doesn't. Or sometimes they both work. So your assignment for today on 8.2 is page 580, 19 to 41, the odds.